So go ahead and stick with those on there. Now, the common name, now this is what drives me crazy about common names. These are the only common names that we're going to deal with up to this point. Like I said, we're going to be using these in the ethers. Because of the location, I'm going to do this one first because it makes the most sense. This carbon right here is bonded to 3 different carbons. So this is considered what they call a tertiary alcohol. So the common name for this is tert-butyl alcohol. Yeah, butyl, not propyl, butyl. Okay? And there's no reason why I hate the common system, because it's not 4 carbons in a row, but the basic feeling of common compound names is names, system, we don't need no stinking system. Tert-butyl. What is this bubbly? Tert-butyl alcohol. And this one right here, now, we had isopropyl when the OH is in the middle. But then when we had this one right here, the OH in the middle there was sec. So that's not iso. But they use iso for this. I don't know why. It's common naming system. They do what they felt like they want to do. So this is iso-butyl, because there's 4 carbons in the entire compound, alcohol. In this chapter, or this section of the chapter, we're not going to deal with these common names very much. We're going to stick with IUPAC. We're going to start basic. But I'm telling you right now, college, organic chemistry, this is the garbage you're going to have to put up. All right, so those are the 4 isomers of C4H9OH. And I hope you understand now why organic compounds are written in this fashion rather than saying C4H10O. The OH is there to emphasize the fact that you're dealing with an alcohol. Okay? Alright, almost there. The last thing we're going to talk about, well, not the last thing, but we haven't talked about uses yet. Alright, so let's talk about uses. Ethanol, methanol are the 2 most common. Ethanol, as you know, is used as an additive to fuel. It's also used as a solvent because it is so polar. Methanol, which is a poison, is used as a fuel. A lot of racing fuel is used in methanol. Indianapolis cars use methanol. And it is also a component in creating other compounds, which ethanol is as well, but methanol much more so. Another common alcohol, rubbing alcohol, we talked about that, disinfectant. Ethylene glycol and propylene glycol are antifreezes. Ethylene glycol is the car antifreeze. Propylene glycol is particularly used in travel trailers for winterizing because it is not nearly as toxic as regular antifreeze. Okay? Another thing too about methanol, I'll throw this in there. Like I said, notice methanol, a poison, is part of NutraSweet, which is what in virtually 80% of all American sodas, diet sodas. It's been banned in the European Union and most other places, but in the United States, it's okay. It's just a little poison. What's it going to do? If you want to read some horror stories, look at the side effects of NutraSweet. It'll scare the crap out of you. All right, last thing we're talking about synthesis reactions. How do we create these things? Well, we're just going to deal with one reaction. And it's kind of based on what we learned in the last chapter, where we take an alkene and add water to it. Now, water is what we call a binary compound. And I'll discuss what that means in just a little bit. An alkene, as you know, has a double bond in it. And when this adds together, this gives you at least one alcohol and no byproducts. This is a pretty clean reaction. So here's an example. If I take the simplest of the alkenes, Fe, which by the way has a common name of ethylene, I don't know why, but it does. You add water. Now water, when we deal with chemical reactions, we don't think of water as H2O, we think of water as hydrogen hydroxide. And we're going to deal with that a lot in the next couple of chapters after this. So when you add, this is what we call a binary compound. It's made up of two ions, hydrogen ions and hydroxide ions. And when it collides here, remember the pi bond is really weak, so it breaks apart. Collision's hard enough, it's going to break these two up as well. The hydrogen's going to go to one carbon, the OH is going to go to the other. So now you've lost your pi bond here, it becomes a single bond. You have all these hydrogens here, and one of these, and it makes no difference which one it is, it's going to be an OH. So you get only one alcohol. This is one way we make ethanol, is by adding these. Now, here's where the problem comes in. Let's take propene. And add water to this. Again, think of this as hydrogen hydroxide. Collision right here breaks the pi bond. The sigma bond stays because it's very strong. But now you actually get two choices of where the hydrogen and the hydroxide go. So let's just focus on the hydroxide. If the hydroxide goes here, then the hydrogen goes here. The hydroxide goes here, then the hydrogen goes here. It's going to break apart this bond right here, the electron here. The hydrogen and the hydroxide break apart. Electron here, and it's going to create a single bond with these over here. I probably should have said that up there, but that's what's going on there, and that's what's going on here. So you get two choices where the OH goes. So you actually get a mixture of two alcohols. You get this, because the oxygen bonding I read it like that. That's an OH group. It's the same thing. And you get this. So you get one propanol, and you get two propanol. And I'm going to focus mainly on the IUPAC system. It's a lot easier. That's how synthesis works. One of the synthesis reactions works for alcohols. Your practice problems. Draw and give IUPAC name for 8 isomers of C5H11OH. Now fine.